Good morning, good evening, good afternoon, good whatever time of day it is, and whatever part of the world you're at right now. Welcome back. And today we're going to be going over a lesson about the relationships of sides and angles in triangles. Okay. So before we take a look at these 6 questions here, numbers 4 through 9, I've already taken the liberty to jot down some notes that are going to be important to understanding what I discussed with those problems. So, the relationship between angles and sides of triangles. Okay, so for the sides, to verify if the sides of a triangle actually form a triangle, choose any two sides, add them, and subtract them. The third side must be a number between, not equal to, but between the sum and the difference. Okay, so one more time. When you're, let's say they give us the sides of a triangle, whether they give us 3 sides or 2 sides, and they ask us to. So if they give us 3 sides, they give us 3 numbers. We're gonna have to add 2 of those numbers, subtract 2 of those numbers, and then evaluate the third number and see if the third number is between the sum and the difference of the 2 that you added and subtracted. If it's between, then it's a triangle. It's said to be a triangle. But if it's not between, if it's equal to or it's outside of those 2 numbers, that means that it is not a triangle. Okay? All right. Now, for the angles, okay, the largest angle is always opposite the longest side, and the shortest side is always opposite the smallest angle. Okay, so let me draw a quick diagram real quick. Let's say these are my angle measures. I don't know, 70, 30, and matter of fact, and let's make that a 80. Let's make that 70 a 80, and then we'll make this 70. Okay. Now, for example, if I'm trying to identify the longest side, like the longest side of the triangle, I'm going to go opposite the biggest angle. So this side over here is the longest side. Okay. And if I wanted to find the shortest, right, the shortest side, this would be the shortest side. Okay, because it's opposite the smallest angle. Doesn't matter what the diagram looks like. It's all about where the angles are. So the shortest side is always opposite the smallest angle, and the largest angle is always opposite the longest side. You can reword those. You can say the longest side is always opposite the largest angle. You can always say the smallest angle is always opposite the shortest side. Okay? But that's pretty much how we identify it. So now that we've gone over these examples real quick, I'm going to go ahead and take a look at these questions here. So for number 4, says which side lengths could form a triangle? Check all that apply. Now, one more time. For each of these, for number 4, all of the examples, just so you all can see it, all of these are 3 numbers. Okay, all of those are 3 numbers. So what we're going to do, we're going to choose any 2. We're going to add them and subtract them. And then we're going to take whatever number that we didn't use, the third number, and we're going to see if that third number is between the sum and the difference. Not equal to, but between. So let's see. All right, so for the first pair, this is going to be, I'm going to do 8 plus 8. All right, 8 plus 8, that's 16. Then I'm going to do 8 minus 8, that's 0. Is 17 between 16 and 0? No. So So this would not be an answer choice here, okay? Because 17 is outside 0 and 16, all right? Let's take a look at the second one. Now for the second one, I'm gonna do 11 minus 2, which is 9. Then I'm gonna do 11 plus 2, which is 13. And I'm looking at this number here. It's 12 between 9 and 13. Yes. So this is one of our answer choices. Let's go to the next one. We have 20 and 6. So I'm going to do 20 minus 6, which is 14. Then I'm going to do 20 plus 6, which is 26. And I'm looking at 15. Is 15 between 14 and 26? Yes, so that is a triangle. The ones I'm checking off all make triangles. That first one that we didn't make a triangle because the third number was outside the sum and the difference. And now let's try the last one. We have 34 and 19. I'm going to subtract. That's going to become 15. And then we're going to do 34 plus 19. That's going to make 3, carry that, 53. Now, is 15 between 15 and 53? No, okay, because it's equal to 15. It can't be equal. It has to be between, remember. Has to be between the sum and the difference, not equal to the sum and the difference. So going back up here, the last one is also not an answer. So the only two that work are the middle two. Okay, answer choice is 2, 11, and 12, and then the answer choice 20, 6, and 15. All right, let's take a look at number 5. For number 5, two sides of a triangle measure 7 feet and 19 feet. Write an inequality to represent the range of lengths for the third side. So once again, in this one, they don't give us 3 numbers. They only give us 2, and they want us to figure out the inequality, okay? Write an inequality to represent range. So when we do that, we're still going to follow the first 2 rules again. We're going to subtract those numbers. That's going to make 8. No, that's not 8. What am I talking about? 12, excuse me. 12. And then we're going to add them. That is going to make 26. So our inequality that they're looking for, x is going to represent the third side, right? And so we'll use, we're going to say x is going to represent the third side. Okay. And it's going to be between 12 and 26. Okay. So that third side, so to make sure we're clear, when you write this, it should look like, just to make sure, 12 less than x less than 26. So it has to be between 12 and 26. This is the inequality right there. Okay. All right. Let's take a look at number 6. Number 6 says two sides of a triangle measure 24 inches and 29 inches. Which of the following lengths could represent the third side? Check all that apply. So once again, we have to add those 2 numbers and subtract them. So I'm going to subtract first. 29 minus 24, that's 5. Then I'm going to do 29 plus 24, which is 53. Okay. So that means that the third side, has to be a number between 5 and 53. 7 works because 7 is between 5 and 53. 31 works because 31 is between 5 and 53. 58, no, because it's not between 5 and 53. And 60, No, because it's not between 5 and 53. So, number 7. Two sides of a triangle measure 3 meters and 8 meters. Write an inequality to represent the perimeter of the triangle. So this time they want an inequality that represents the perimeter. Okay, the perimeter means you have to add up all 3 sides. Okay, now the first we still have to do what we originally started off by doing, which was subtracting the numbers and adding the numbers. So 8 minus 5 is 3. 8 plus 3. Oh, excuse me. Yeah, 8 plus 3 is 11. So 8 minus 3 is 5, and 8 plus 3 is 11. Now, this gives us the range of the third side. Okay? That would be the inequality if we were looking for the range of lengths. Okay? If we're looking for the inequality to represent the perimeter, we just have to add everything up, okay? So if I do 8 plus 3 plus 5, 8 plus 3 plus 5, and then 8 plus 3 plus 11. We know that the third side can't equal 5 and it can't equal 11. So these are going to be our restraints. They're not going to equal those things. The perimeter just has to be between those. So 8 plus 3 plus 5, that's 11 plus 5, which is 16. And then 8 plus 3 is 11, plus 11 is 22. So our perimeter, the perimeter has to be between 16 and 22, but not equal to those things. Oops, let me write that a little better. So this is for the perimeter, all right? And that's the answer that we're looking for. This is the inequality for the perimeter that we wanted. All right, number 8. In triangle DEF, DE is 18 feet, EF is 5 feet, and DF is 19 feet. Order the angles from least to greatest. Now, as you can see in number 8, they didn't give us a diagram, so we should just draw our own. Okay? And I'm going to label it D, E, and F. Now, DE, that's 18. EF is 5. And DF is 19. Okay? Now, for this one, we need to revisit this right here. We said that the largest angle is always opposite the longest side, and the shortest side is always opposite the smallest angle. Okay? So we got to think about opposites. So if I want to identify the largest angle, and angles are here are going to just be the letters. So I need to look for the, we got to go from least to greatest, okay? It says least to greatest, so smallest to largest. So the smallest angle is opposite the smallest number, the smallest side. The smallest side is 5, right? Smallest. Or shortest. We'll say shortest because we're talking about side lengths. So this is the shortest side. So opposite is the smallest angle. So smallest angle is angle D. Okay. And then the next smallest angle would be F. And then that means that the largest angle is E. And we'll say largest. Okay? So we put them in order from least to greatest. D was the smallest because it's opposite the shortest side. F was the next smallest or the next biggest because it was opposite the middle side. And the largest side is 19, which makes E the largest angle. Okay? Now number 9. It says order the sides of the triangle below from least to greatest. All right? Well, we need to know all 3 of the angles. So the first thing we need to do is add 61 to 56. That's going to be 117. And then we're going to do 117 subtracted from 180, which is going to leave us with 93. Oh, 3. That becomes a 10. This becomes a 7. 63. So this angle right here is really 63 degrees. Now we need to look for the side lengths, okay? So side, and we're going from smallest to greatest, okay? And greatest to be down here. All right, so the smallest side, we need to look for the smallest angle. Well, here's the smallest angle. Angle S. So the shortest side would be RT. So RT is the shortest side. All right. Well, what's the next shortest side? What's the next number after 56? 61. So 61 is right here. So that means that the next shortest side is ST, right? 61 is angle R. So side ST is the next shortest side. Now, which means that the biggest angle is angle T, which means that the longest side is RS. All right. And that, ladies and gentlemen, will conclude our lesson today on the relationships of sides and angles inside triangles. See you all later. Deuces.